Now that we understand how to pass arguments from one screen to another, let's try something slightly more complex, inspired by a familiar example, such as browsing contacts. Of course, using real contacts and complex data structures would introduce unnecessary complexity at this stage. So we will keep the example simple. Let's consider the phonetic alphabet: Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, and so on. The idea is to create an application where the first screen displays a list of items. Each item contains a single character, such as A, B, C, together with its corresponding phonetic word. When the user selects one of these items, we navigate to a second screen. On this screen, we display a larger version of the selected character, along with its corresponding phonetic word. There is a small additional complexity. The alphabet contains more characters than can fit on a single screen. So we need to allow vertical scrolling to let users move up and down the list and select the specific letter they want. To implement this example, we first need to focus on two aspects of the language. The first one is quite general and mainly comes from Dart, the concept of a list. A list is a generic data structure widely used in many programming languages. The reason we are discussing lists here is also connected to a specific feature of Dart. Dart does not have traditional constructor overloading like some other object-oriented languages. Instead, we can define multiple name constructors within the same class. This gives us flexibility in how we create instances of a class, even without classical overloading. Each constructor starts with the class name, followed by a dot and an additional identifier. In this way, we can provide different ways of initializing objects depending on our needs. This concept is not directly related to a graphical user interface. Rather, it's a fundamental language feature. Understanding it helps us structure our data properly before thinking about how it will be displayed on the screen. The second concept, instead, is very much related to Flutter. Here, we introduce the idea of a list view, which allows us to display a scrollable list of elements. So far, we have mainly worked with static layouts, where the number of widgets was clearly defined in advance, and their arrangement was fixed. In those cases, the structure of the interface did not depend on dynamic data. Now we need a more flexible solution. A list view, as the name suggests, provides a visual representation of a list of elements, allowing us to define a potentially long list of items that the widget will automatically display according to the available screen space. One of the key advantages of list view is that it handles scrolling automatically. If the number of elements exceeds the vertical space of the device, users can simply scroll up and down to access all items. We do not need to implement complex algorithms or write sophisticated layout logic. The scrolling mechanism and layout adaptation are built directly into the widget. In practice, what we need to specify are the main characteristics of the list, for example, how many items it contains, and how each individual element should look. Once we define the structure of a single generic item, Flutter can replicate it as many times as necessary to represent the entire list. This makes List View a powerful and convenient tool for displaying collections of data in a clean and scalable way. So, if we want to start implementing this example in code, we begin with the usual ingredients. We import the necessary Flutter packages, define our main function, and create the top-level stateless widget, typically called My App. If we then move to the home page, things become slightly more interesting. In this case, the home page is a bit more sophisticated than before. As you can see, we create a list of strings, as mentioned. List is a generic class in Dart. Then we initialize the list with all the phonetic alphabet words corresponding to the different characters, Alpha, Bravo, Charlie, and so on, up to Yankee and Zulu. This list will serve as the data source for the visual components that we will display on the screen. Now that we have all the ingredients, we can focus again on the build method. As usual, we return a scaffold. The app bar is very simple, with a basic title as NATO alphabet. The interesting part, however, is the body of the scaffold, which is now a list view. To create a dynamic list, we use List View Builder. This builder requires a few important parameters. The first one is item count, which specifies how many elements the list should display. In our case, this is straightforward. Since our data source is a list of strings, and every list has a length property, we simply reuse that value. The second parameter is item builder. As mentioned earlier, we must define how each individual item should be built. The builder is a function that takes two parameters, the usual context and the index, which represents the position of the element within the list. Using this index, we construct each item, typically a list tile. The title of the tile is a simple text widget displaying the word at position index in our list. We use a larger font size for better visibility. We also use the leading property of the list tile, which allows us to play a widget before the title. In this example, we introduce a circle avatar. Its child is a text widget displaying the corresponding letter of the alphabet. Since index is a number, we convert it into a character by adding 65, the ASCII code for A, and then transforming the result into a string. In this way, index 0 becomes A, index 1 becomes B, and so on. Finally, we define the onTap callback, which specifies what happens when the user taps on one of the list items. Once again, we use navigator push for the same reason as before. We want to pass arguments dynamically. We create a material page route whose builder returns the target screen. This screen receives two parameters, the letter, obtained by converting 65 plus index into a string, and the word, which is simply the element at position index in our list. This completes the connection between our data structure and the user interface. The list provides the data, the listview.builder renders it dynamically, and the navigation allows us to move to a detail screen when an item is selected. To conclude, let's focus briefly on the second screen, the stateless widget that displays the details. As we have seen in the previous slide, this screen receives two parameters, letter and word. Both parameters are marked as required, and both are declared as final string, since their values do not change once the widget is created. The build method is quite simple. We return a standard scaffold with a minimal app bar, whose title displays the word itself. In the body, we use a column centered on the screen. First, we display the large letter using a text widget with a font size of 120 and a bold font weight to make it visually prominent. Then we insert a separator, typically a sized box, to create some vertical spacing. Finally, we display the phonetic word using a smaller font size, for example, 40. The result is a clean and clear detail screen that emphasizes the selected letter and its corresponding word. After focusing on how to send data from a source route to a target route, The next lecture will explore the opposite, how a target route can return data to the source route.